Hi guys, in this tutorial I'll demonstrate how you determine the tension T for this kind of arrangement. Now you really have to be very careful with this question because you want to find the exact values which you're working with. But I'll demonstrate how you use the values once you figure out what they are and what their units are. So in this case, we're trying to determine what tension T is. The first thing that you have to do here is to determine the equilibrium position. So it's the tension T that just allows you to lift this beam up. Now in this case, the tension T is going to be acting somewhere here, and the question does specify that the angle doesn't, it changes only slightly, such that we can assume that we can neglect it in a way. So you have the angle theta. For the case that we'll be dealing with, theta is going to be taken as 60 degrees. Now apart from that, we have the weight of the beam that is going to be acting downwards through the center. So of course we're assuming the beam here, or the slab here, is uniform, so that the weight is located at the center. Now, for simplicity, we're going to pick the point of rotation and use the sum of rotations equals to 0, and by placing it there. And then we'll make another assumption that the slab here is very thin, and doing so allows us to assume that the x component of the slab will not cause rotation if the slab is very thin. If it is not thin, as you can see this one, clearly the line of action will not pass through the center of rotation, implying that here it's supposed to cause rotation as well. But if we assume it is very thin, then it will not cause any rotation. So only the vertical component of the tension T will actually cause rotation, and the vertical component in terms of T and theta will be given by T sine theta, and theta is 60 degrees. Now the only thing that we have to do here is figure out what the weight here is, because we know the length here that is going to be perpendicular to that will just be the length of the slab itself. And for our case, I'll use these values. The length is 36 meters. So use 36 meters there. So if we sum moments about point A here, so sum of moments about A equals to 0, we're going to have T sine 60 multiplying, that's 36 meters. Okay, 36 meters. Now, this is clockwise, so we're taking it as positive, but the weight will be causing clockwise moments, or minus, then the weight, assuming it's on the middle again, this is going to be 18 is equals to 0. We see that from here, if we make T subject, we're going to end up with this equals to the weight multiplying 18 divided by 36, then sine 60. Now the problem here is, what is the weight here? So to find the weight, you really have to be very careful. In this case, you see the student here is writing the weight as megagrams. If the weight is in megagrams, then you know to say 4.52 megagrams to 2 kgs. This is going to be written as 42,520 kgs. If you convert megagrams to kgs, this is how it is going to look like. Now, this, of course, if you multiply it by 9.8, it's going to give you what the mass is in what the weight is in newtons, and that is going to be 416,696 newtons. So this is if we're taking the units here to be megagrams. But if at all, if let's say the units here were given as megagrams per meter, then this changes everything. It will mean that now the mass of this beam, since this is per meter, we have to factor in the length of the beam now, so that the mass can now be seen as, I like calling this the mass length density. So say it's 4.52 megagrams per meter, multiplying this by 36 meters that are available. The meter in the meter will cancel out, giving us the mass now as 162.72 megagrams. Converting this to kgs, we end up with 162,720 kgs, and eventually we multiply this by 9.8 to get the weight. We get the weight as 1594656 newtons. Of course, we want this in kilonewtons, so the decimal point moves somewhere there. We get 1594.656 kilonewtons. So this is what will bring this side, so that now we can easily calculate what our tension is. So we have 1594 0.656 by 18 divided by 36 sine 60. Doing this, let's see what we get there. This gives 920.675. This will be kilonewtons. So this is what comes out as our tension T. Alright guys, so share and like the video. If I get more than 30 likes, I'm going to upload the second part of this question. Alright guys, see you in the next part.